Imagine you have a Node.js API running on port 3000. Someone types your domain into a browser. How does that HTTP request on port 80 get to your Node.js app on port 3000? Option 1, change your app to listen on port 80. But port 80 requires root privileges. You'd be running Node.js as root if your app is compromised, the attacker has root access to your server. Option 2, use a firewall rule to redirect port 80 to 3000. This works, but now your Node.js app is directly handling every incoming connection. No SSL termination, no rate limiting, no ability to serve static files efficiently, no caching. Option 3, put Nginx in front. Nginx listens on port 80 and port 443. It accepts connections, handles SSL, and forwards the request to your Node.js app on port 3000. Your Node.js app stays on an unprivileged port, never needs to run as root, and Nginx handles all the concerns a web server is built for. Option 3 is what every serious Node.js deployment does. Nginx as a reverse proxy is not optional complexity, it's the correct architecture. It's the layer that handles all the things Node.js wasn't designed to handle efficiently: SSL termination, connection queuing, static file serving, and rate limiting. A proxy, in networking, is something that acts on behalf of something else. A forward proxy acts on behalf of clients, it's what corporate networks use to control what websites employees can access. A reverse proxy acts on behalf of servers. When a client, a browser, sends a request to your domain, it connects to Nginx. Nginx receives that connection and, based on the rules you've configured, forwards the request to one of your backend servers, in our case, Node.js on port 3000. Node.js processes the request and sends a response back to Nginx. Nginx sends that response back to the client. From the client's perspective, it's talking directly to your domain. It has no idea there's a Node.js process on port 3000. It doesn't know what technology your backend uses. It doesn't know how many backend instances are running. Nginx is the face of your application. This intermediary position is where Nginx earns its keep. Because all traffic passes through Nginx, Nginx can log every request, apply rate limiting before requests reach your app, strip or add headers, cache responses for static or slow changing content, terminate SSL so your backend doesn't have to handle encryption, and route different URL paths to different backend services. A reverse proxy is not a bottleneck, it's a feature multiplier. Nginx adds an entire platform of capabilities to your Node.js application. Before we write any Nginx configuration, you need the mental model. Nginx thinks in terms of server blocks and location blocks. A server block defines how Nginx handles requests for a specific server, usually identified by the domain name and port. Server_name api.myap.com and listen 80 in a server block means this block handles requests for api.myap.com on port 80. Inside a server block, location blocks define how Nginx handles specific URL paths. Location/means, for requests to any path. Location/static means, for requests to /static and everything under it. Location equals /health means, only the exact path/health. The mental model, requests come in, Nginx matches the server block by domain and port, then matches the location block by URL path. The matching location block determines what happens: proxy to node.js, serve a file, return a redirect, or return a specific response code. This two-level matching, server then location, is how you can run multiple applications on one server. You have one Nginx server block for api.myap.com that proxies to node.js on port 3000, and another server block for app.myap.com that proxies to a different node.js process on port 4000. One server, two applications, zero port conflicts from the outside world. Keep this mental model in mind: server block selects by domain, location block selects by path. Nginx is in Ubuntu's default app repository. Installation is one command, sudo apt update, and in sudo apt install Nginx. After installation, Nginx starts automatically. Verify it's running, system.status Nginx. You should see active, running. To verify Nginx is actually serving traffic, curl http://localhost. You should see an HTML page saying welcome to Nginx. This confirms Nginx is running and responding on port 80. Nginx's key directory /etc/Nginx is the configuration directory. Everything that configures Nginx lives here. /etc/Nginx/Nginx.conf is the main configuration file. /etc/Nginx/sites available is where you store your site configurations, one file per site. /etc/Nginx/sites enabled is where you enable configurations by creating symlinks to files and sites available. /var/log/Nginx contains the access and error logs. /var/www/html is the default document root for static files. The sites available/sites enabled pattern is Nginx's way of letting you maintain configuration files for multiple sites while only activating the ones you want. Create a config in sites available. Run lns to create a symlink in sites enabled. Run nginxt to test the config. Run system to reload Nginx to apply it. We'll work through this pattern in the next chapter. Let me trace exactly what happens when a user visits your application. Step 1. The user types nyapp.com in their browser. Their DNS resolver returns your server's IP address. The browser opens a TCP connection to port 443 on your server. Step 2. Nginx accepts the connection on port 443. Because you've configured SSL, Nginx handles the TLS handshake using your certificate. The connection is now encrypted. Step 3. Nginx reads the HTTP request that arrived through the encrypted connection. It sees get/API/users HTTP/1.1 with host, nyapp.com. Step 4. Nginx matches this against its server blocks. It finds the server block with server_name nyapp.com and listen 443. It then matches the request path/API/users against the location blocks in that server block. It finds location/API and matches. Step 5. The location block says proxy_pass http://localhost 3000. Nginx opens a new connection to port 3000 on localhost, your node.js app, and forwards the request. Step 6. Node.js processes the request and returns an HTTP response. Step 7. Nginx receives node.js's response, encrypts it using the TLS session, and sends it back to the user's browser. The browser received a response. The user is happy. Node.js never touched SSL. Nginx handled the encryption, the logging, and the connection management. Understanding what to give to Nginx versus what to give to Node.js is important for designing an efficient architecture. Nginx is optimized for accepting many concurrent connections with very little memory. Nginx can handle tens of thousands of simultaneous connections with minimal RAM. Serving static files directly from disk at maximum speed. SSL termination. Nginx's TLS implementation is battle-hardened and highly optimized. Rate limiting and connection throttling. Serving cached responses. Node.js is optimized for executing JavaScript business logic. Connecting to databases and external APIs. Generating dynamic responses based on user data. Running your application code. The correct division, static files, images, JavaScript, CSS, HTML, go directly through Nginx, they never reach Node.js. Dynamic requests go through Nginx to Node.js. SSL is terminated at Nginx. Node.js communicates with Nginx over plain HTTP on localhost, which is secure because localhost traffic never leaves the server. This matters for performance. If your Node.js app handles a request for a 2 MB image, it reads the file from disk and sends it over its network connection. If Nginx handles that same request, it uses sendFile, a system call that transfers the file directly from disk to the network without copying through application memory. Nginx serves static files at dramatically lower CPU cost than Node.js. Let Nginx do what Nginx does best. Let Node.js do what Node.js does best. The main Nginx configuration file is /etc/nginx/nginx.conf. If you open it, you'll see it's structured in blocks nested inside each other, like this. At the outermost level is the main context. This contains global settings, the number of worker processes, the path to the PID file, and includes for additional configuration files. Inside the main context is the events block. This configures connection handling. Worker_connections 1024 sets how many simultaneous connections each worker can handle. Inside the main context is the HTTP block. This is where all HTTP-related configuration lives. The HTTP block can contain gzip settings, log format definitions, upstream blocks for load balancing, and server blocks. Each server block inside the HTTP block defines one virtual server, one application or domain. A server block contains the port to listen on, the domain names this block handles, SSL certificate paths, and location blocks. Each location block inside a server block handles a specific URL pattern. Location blocks contain proxy_pass to send traffic to a backend, route to serve files from a directory, return for redirects and error responses. The include directive lets you organize configuration across multiple files. /etc/nginx/nginx.conf includes /etc/nginx/sites enabled /*. This is why you can put your application configurations in separate files in sites enabled. Think of it like nested containers, main events plus HTTP server location. If PM2 is running 4 cluster workers on ports 3001, 3002, 3003, and 3004, or all on port 3000 in cluster mode, Nginx can distribute traffic across all of them. In cluster mode, PM2 handles the load distribution internally. All instances share port 3000 and PM2 round-robins connections between workers. Nginx just proxies to localhost 3000 and PM2 handles the rest. But if you have multiple separate Node.js applications, perhaps an API on 3000 and a separate auth service on 4000, you can use Nginx's upstream blocks to define a group of backend servers and load balance between them. The upstream block defines a named group, upstream API_backend, server localhost 3000, server localhost 3001. Then in your location block, proxy_pass http://API_backend. Nginx distributes requests across all servers in the group using round robin by default. Upstream configurations also support health checking with the least_con directive to send traffic to the server with fewest active connections, and IP_hash to pin clients to specific servers based on their IP address, useful for session persistence without Redis. For most Node.js deployments using PM2 cluster mode, you'll proxy to a single port and let PM2 handle load balancing. Nginx upstream blocks become relevant when you have multiple separate Node.js processes. Every time you change an Nginx configuration, you must test it before applying it. A syntax error in your Nginx config causes Nginx to refuse to reload, leaving your server either running the old config or, if something went wrong, returning errors. Nginx test the configuration. Nginx parses all config files and reports any syntax errors or invalid directives. If it outputs test is successful, the config is valid. Never skip this step. Sudo Nginx is equivalent. Nginx can be run as your user if you have read permission to the config files. After a successful Nginx system will reload Nginx. This sends a SIOP to the Nginx master process, which causes it to reload its configuration and gracefully replace worker processes. Existing connections finish with the old config, new connections use the new config. No downtime. Don't use system to restart Nginx unless you need to restart stops and restarts Nginx, causing a brief interruption to all active connections. Reload is always preferred for configuration changes. If you make a mistake and break Nginx, system.status Nginx shows the current state. Journal.yu Nginx no pager in 50 shows the last 50 log lines from Nginx's systemd journal. This is where startup errors appear. The Nginx error log at /var/log/nginx/error.log also contains useful diagnostic information. Always, edit config, Nginx system.reload Nginx. Never skip the test. A fundamental question about why the reverse proxy exists. Your Node.js API is running on port 3000. A user visits your domain on port 443, HTTPS. Which layer handles the SSL certificate and TLS encryption? Option A, Node.js. It handles SSL directly by loading the certificate and key. You can configure Node.js to use HTTPS with the HTTPS module. This is technically possible, but it means Node.js handles encryption for every connection. You have to manage certificate renewal inside Node.js, and you lose Nginx's connection handling and load balancing. This is not recommended for production. Option B, Nginx. It terminates TLS, handles the encrypted connection, then proxies to Node.js over plain HTTP on localhost. This is the correct production architecture. Nginx is optimized for TLS. Node.js communicates with Nginx on localhost, which never leaves the server. Certificate management is centralized at Nginx. Option C, the cloud load balancer handles SSL, so neither Nginx nor Node.js needs to. This is valid for certain cloud architectures, but for self-hosted servers, Nginx is the correct answer. Option D, the operating system handles SSL transparently. No, SSL/TLS is an application layer protocol handled by the application, not the OS. The answer is B, Nginx terminates TLS. This is the correct architecture for Node.js production deployments. Nginx handles encryption, Node.js handles business logic, and they communicate over localhost where plain HTTP is completely secure.